All right, today we're starting what's called complex numbers, all right? This is brand new to you guys. The only thing that's brand new is the concept of imaginary numbers. Adding, subtracting, and multiplying, all that stuff, simplifying, it's all going to be the same kind of math, but now you're going to have I's in your answer. They're imaginary. So let's just talk about that for a second, right? The definition of I, where does an imaginary number come from? Forever, you guys were taught that, like, if you had the square root of -2, you can't take the square root of a negative number. How many times have you guys heard that? That statement's not exactly true. You can take the square root of a negative number. It's just not a real number. It's not a number that you could, like, plot on a graph. It's imaginary. So what we need to understand, these two things here at the top are the most important for today and moving forward. The square root of -1 is equivalent to the letter I, little lowercase I. And if you have I squared, that value is -1. You will never, ever, ever have I squareds in your answer. You'll see why in a little bit. But you can have I's in your answer, you just can't have I squared. So you denote an imaginary unit with a lowercase I. It represents the square root of -1, and it's used to handle the square root of a negative number, right? So let's talk about simplifying to make smaller, right? If you had the square root of -20, I would tell you guys, and this time I'm going to tell you guys to do all of them, you're going to break it up. The first thing I want you to do is take -1. Make sure you write the -1 underneath the radical so you remember, oh, that's an imaginary. It's hard to see. All right, what would we break 20 into?
10 and 2.
Okay, 10 and 2. What else could we do? 4 and 5, right? We want to do a perfect square and a non-perfect square. So 4 times 5. So when we simplify this, what is the square root, guys, of -1?
2.
No, what's the square root of -1? I. What's the square root of 4? 2, and the 5 has to stay inside. So you would simplify this. You would write 2i and then the square root of 5. You treat I almost as if it was just a variable. But you know this is imaginary because there is an I there. All right, so let's just do some simplifying stuff. Then we'll talk about adding and subtracting and all that. All right, first thing I'm going to tell you guys to do every single time, get in the habit. As we do this more and you guys see this more in math, you won't have to do it. But I want you to rewrite this as the square root of -1 times 3. Because when you have a negative underneath the radical, you know it's imaginary. So what can we take out here? What is the square root of -1?
-1.
No, what's the square root of -1? It's an I. And do we know what the square root of 3 is? No, so you're just going to rewrite this as a little I out in front times the square root of 3. That's it. You simplify like you would any other time, make your radicals smaller. It's just a matter of now we got to account for that negative. So I have a negative underneath the radical. I'm going to put a -1 underneath there. And then what's a big perfect square and a small non-perfect square that make up 48? 8 and 6. But they both have hidden stuff in them. So what's bigger? It's a bigger perfect square.
Oh, 4 and 12.
Okay, 4 and 12. That works too. But then you'd have to break down 12 again. What about 16 times what? 3, yep. So when we go ahead and simplify this, what is the square root of -1? I'm going to write it up here. What is the square root of 16? 4, and we don't know the square root of 3, correct? So we would rewrite this as how? 4i square root of 3. No, you could write I4, but it just looks better. It's like saying 3x rather than x3, you know? All right, now we're multiplying radicals. I just want to show you guys this. If you don't do it this way, that's okay, but I want to show you this. If you're multiplying radicals, you can rewrite everything underneath the same radical, right? So this is really the square root of -1 times 7 times the square root of -1 times 7. When you are taking out perfect squares, guys, it's a pair underneath the radical, right? What do you see pairs of? I have a pair of -1s. So that would just be a -1 times, I have a pair of 7s, right? What's -1 times 7? Negative 7, all right? Some of you are like, well, where's the i's and all that? Well, think about it. What is the square root of negative 1? It's I. What's the square root of negative 1 here? It's I, right? What's I times I equal? I squared, right? And the first slide, what did we say I squared was? The same as negative 1. We have to remember that I squared equals negative 1. And then if you multiplied 7 times 7, what's the square root? 7 times 7 is what? 49? So what's the square root of 49? 7. I think it's easiest to write out all of the factors underneath and then just take out pairs. That's the easiest way to do it. So if I look here, what can I break negative 6 into? What times what gives you 6? Okay, so I have negative 1 times 2 times 3, right? And then what about 10? I have negative 1 times what? 2 times 5? All right, what do we have pairs of?
2.
Okay, I got a pair of 2s. 2 times 2 is 4. What's the square root of 4? 2. That's where that comes from. And then I have a pair of what? Negative 1s. Because think about it. Square root of negative 1 is I. Square root of negative 1 is I. I times I is I squared. That gives you negative 1. And then what stays on the inside? 3 and the 5. So you have a negative 2 on the outside. And what's 3 times 5? 15. Negative 2 square root of 15. You can't say a negative 6 times a negative 10 gives you a positive number. That's not how that works. That's why you have to make sure you take the i's out of the negatives. So the same way that you can combine two small houses when you're multiplying gives you one big house, you could do the same thing when you're dividing. Do you see how these are both underneath a radical? So let's go ahead and break down 48 as much as we can. We can go to perfect squares and non-perfect squares if we want to, or you can just say, what times what, guys, gives you 48? Okay, negative 1, I like it. 16 times 3. Okay, leave it underneath. Don't worry about taking anything out. And then what can we break 24 into? 4 and 6. Okay, good. So since they're both underneath a radical, you can go ahead and simplify some things. What can I simplify?
16.
Okay. What 4 goes into 4 one time, right? 4 goes into 16 how many times? 4, okay. What about 3 and 6? 3 goes into 3 how many times? Once. And 3 goes into 6 how many times? Twice, okay. So what can I simplify on the top? What is the square root of negative 1? It's I. What is the square root of 4? Okay, so this is I times 2. So I'm going to write it as 2I over what? The square root of 2. Does anybody see a problem with that? Square root of 2 on the bottom. How do you get rid of that square root of 2 on the bottom? You're going to multiply the top and the bottom by the square root of 2. You have to rationalize. So this becomes 2I times the square root of 2 over, what's the square root of 2 times the square root of 2? 2. It's the square root of 4, which equals 2. And then the last thing we can do, what can we do with these 2's that are on the outside? You can cancel them. Yep. So your answer just becomes I times the square root of 2. Let's talk about 70. Okay, so negative 1 times 7 times 10. Perfect. What about negative 7? Negative 1 times 7. Do you see anything on the top and bottom that's exactly the same? The negative 1 and the negative 1. Good. What else? 7 and the 7. So what are you left with?
70. Square root is 10.
Square root of 10. That's it. Perfect. So simplifying is the exact same way that we've simplified every time, all these different problems, but now it's just that negative 1 underneath the radical. It means something a little different. So now we're going to talk about the next step. Whoops, I forgot to erase that. We're going to talk about something called a complex number. Complex number has two parts. It has a real part and an imaginary part. This is what's called standard form of a complex number. In standard form, a plus bi, a is the real part and bi is the imaginary. How can you tell, looking at 7 plus 3i, what's the real part, what's the imaginary part?
3i.
Is what? Imaginary. How do you know that? Because it has an I with it. Very good. All right, so if I said to you guys, what is 7 plus 3x? Can you combine that?
There's 73.
No, you can't because they don't have like terms, right? Same thing with imaginary numbers, complex numbers. Real goes with real, imaginary with imaginary. So why am I saying that, guys? We are going to treat I like a variable, like it were an x or a y or anything like that. We're going to combine like terms. We're going to FOIL just like we would. But when we get I squared, we're going to replace it with -1, and I'll show you exactly what that looks like. It's super easy, I promise. So go ahead and do these last examples, and then we're done. All right, look at 13. What's going on in between these two parentheses? You're adding. Guys, how do you add polynomials? You combine what? Like terms. So what is like? Real stays with real. What is 3 plus 7? 10. Imaginary with imaginary. What's -4i plus 6i?
10.
-4 plus 6 plus 2i. That's it. You cannot combine anymore because part of it is real, part's imaginary. That's like saying 10 plus 2x. Can't do anything else. Does that make sense? All right. Look at 14. What are we doing in between each parenthesis? We're adding again. Good. So real, guys, with real. What is 2 plus 4? 6. Perfect. Then what's -7i and a -5i?
-12.
Perfect. -12i. Make sure you put that I. Because that's telling you, hey, part of this number is real and part of it is imaginary. All right. What do we have to do with 15 before we can start combining like terms?
The 16 and 5. Like the parentheses first.
Okay. I have to do what? Distribute the negative. Do you see this -1 right here? I have to distribute that first. So let's go ahead and just rewrite. I have 4 plus 16 plus 5i minus 5 minus 2i. And now real goes with what? Real goes with real goes with real. What's 4 plus 16? 20 minus 5. 15, good. And then imaginary with imaginary. What's 5i minus 2i? 3i plus 3i. That's it. You're just combining like terms as if it were a variable. And then you guys get kind of confident and you're like, oh, seriously? Now we got to change it up. What are we doing here in between these two parentheses? We're multiplying. How do you multiply two binomials, guys? You FOIL, right? What did I tell you? You're never going to have in your answer what? I squared, right? You're never going to have I squared because when you have I squared, that is equal to the value of -1. I'll show you why this matters in a second. FOIL this. What's 2 times 4? 8. What is 2 times 3i? Plus 6i, good. What's -i times 4? Minus 4i. And then what is -i times 3i? It's minus 3i squared. As soon as you see that I squared, guys, I'm going to tell you to cross off the I squared and change the sign in front of that number. It becomes real. Why can you do that? Well, think about this. If I have minus 3i squared, this is -3 times. What is the value of I squared? -1. So when I multiply -3 times -1, what do I get? A +3. Soon as you see an I squared, I'm going to tell you guys, cross it off, change the sign in front. So now I can combine real with real. What is 8 plus 3? 11. And imaginary with imaginary. What's 6i minus 4i? Plus 2i. Perfect. Good job. 2 more little things and we're done. What is 3 plus 2i quantity squared? What does that really mean? Timesing it by itself or each other. Very good. So it's 3 plus 2i times 3 plus 2i. So let's FOIL, guys. 3 times 3 is 9. 3 times 2i plus 6i. 2i plus 3 plus 6i. And 2i times 2i plus 4i squared. As soon as you see that I squared, what do we do? We're going to cross it off and change the sign in front. So now I have 2 real numbers that I can combine. What is 9 minus 4? 5. And then what's 6i plus 6i? There you go. Perfect. What do you guys notice about 18? It's the same thing, but plus or minus, right? Okay, so let's see what happens here. Multiply. 3 times 3 is 9. 3 times negative 2i. Negative 6i. Great. 2i times 3. Positive 6i. What's 2i times negative 2i? Minus 4i squared. As soon as we see that I squared, what do? We cross it off and make it positive. So now we combine real with 9 plus 4 is 13. And what happens here in the middle with a negative 6i and a positive 6i? They cross out. So what do you guys notice happened to our i's? Where'd they go? They canceled out. These are called complex. We're going to work with this tomorrow. Complex conjugates. Does anybody know what the word conjugate means? Opposites, right? These are complex conjugates of each other. And the reason that we have to know that, we have to use that, is just like we're not allowed to have a square root in the denominator. What do you think we're not allowed to have in the denominator? An I. Can't have i's in the denominator. So what we're going to do, you'll see it tomorrow, is we're going to multiply by the complex conjugate. And once you do that in FOIL, the i's will cancel out of your denominator. But we'll do that tomorrow. I do have a web assign that I'm going to put up. I'm probably going to make it due Thursday because you guys can't access it right now. And I'm not going to get through the whole lesson. I should get through everything tomorrow, but just to give you guys a little extra time. But, keep checking once you get home, Canvas comes up, because some of this is going to be on it, so you can get ahead of it, because it's going to be, a pretty lengthy assignment because there's a lot in this. But I'll get it up as soon as I can.